We'd like to get a feel for how radians and degrees relate to each other. You might be more familiar with degrees than radians at this point, because we hear about them more. So it'd be nice to know, how do those relate, so we can start kind of figuring out how they relate to each other. One of the ways of doing that is by being able to convert. So, like, I know that an inch is about 2.5 centimeters. I can use that as a conversion factor. We'd like to develop one of those for degrees and radians. Before we do that, we're going to just mention here, because I'm going to use this in a second. Pi is the ratio of the circumference of a circle to its diameter. Any circle, all of them, everywhere, kind of amazing. We also know the diameter is 2 times the radius, so I'm going to write it like that. If I multiply the beginning and the end here by 2 times the radius, we have the circumference of a circle is 2 times pi times the radius, which might be familiar. We're going to use that in a second here. We know from the definition, 1 radian cuts off an arc of the circle whose length is equal to the radius of the circle. I'd like to know how many radians are in a complete circle. That's at least a starting off point. Well, let's see. I can do the same kind of idea. How many radians are in a complete circle? Well, the arc length for a complete circle, right there, 2 times pi times the radius. And the numbers aren't the same, but the ratios are the same. So this is a proportion. We're going to solve a proportion the way we always do, which is by cross multiplying top of one by the bottom of the other. So I have 2 pi r times 1 and r times x. What I really want is this x, how many radians in a complete circle. So I'm going to divide both sides by r. We can do that. R isn't 0 because it's a circle. It has a radius that's a positive number, and there we go. There are 2 pi radians in 1 complete revolution. Well, from there, we already know how degrees go. There are 2 pi radians in 1 complete revolution, and there are 360 degrees in 1 complete revolution. Which means, since those are both 1 complete revolution, those are equal to each other. If I divide by both sides by 2 pi, I get a unit fraction, which I can reduce, actually. We might as well. Or I can divide both sides by 360 and also get 1, since these are 2 quantities that are equal to each other. And get pi over 180. So if I have a measure, an angle measure in degrees, and I would like to change it to radians, here's my conversion factor. I can take my degree measure, or my radian measure. I'm going to say that again because I'm not sure I said it the right way around. If I have an angle in radians and I would like to change it to degrees, I can multiply the angle in radians by 180 over pi and get the equivalent degree measure for that angle. If I want to go the other way, if I have an angle in degrees and I want to change it to radians, I can take my angle in degree measure and multiply it by pi over 180 to get the radian measure of that same angle. Let's just do one real quick here, each way. Suppose I have an angle that I know has a measure of 2 pi over 5 radians. 2 pi over 5 radians. How big is that? I don't know. I know about how big 1 radian is, but this isn't that. So let's see. I'm going to take my angle in radian measure. multiply it by 180 and divide by pi. That's my conversion factor. Now I got pi. I got pi. 5 divides into 180, 36 times. 2 times 36. Oh, 72 degrees. Okay, so that's pretty big, but less than a right angle. My radian measure was 2 pi over 5 radians, 72 degrees. Going the other direction, suppose I have an angle of 135 degrees and I need to know what that is in radians. I'm going to take my angle in degree measure and multiply it by pi over 180. So I'm multiplying by pi, dividing by 180. 45 divides into both of those. You can do it on a calculator too if you want. You can do it on a calculator too if you want, with the awareness that we want exact radian measure, and that's with the pi in there. As soon as you round something on a calculator, it's not exact anymore. It's an approximation. Exact. We want the pi. So 135 divided by 180 is 3/4. This is 3 pi over 4 radians. And that's converting back and forth between degrees and radians.